about significant digits, so you can take notes on them if you wish. You may want to pull up the graph slides that I put up as well. I think each set consists of 6 slides. I believe I put 2 slides on a page if you're a paper person and print them out like I do. You may want to have them handy. Of course, you do not, but they are posted in week 5. So we'll do much like we did last week. I'll give you an introduction about significant digits, and this is in response to the homework that you did last week using your Excel files and inputting your values. Okay, and then I'll give you another quick introduction using Excel, and then I'm going to turn you loose with 2 assignments this week. One is a quiz on significant digits, and another is using an Excel file to make some graphs. All right, so let me first start and open the floor. Are there any questions that you have in general about anything we've done? I'm still in the midst of grading your rewrite from your original exercise when you did your hypothesis and experimental design. So don't worry, I know I've got to do it. They should be under, oh boy. All right, here we go. Damn. All right, now you should see it. Don't understand why it does that to me. Don't see me. Anyway, do you see it now? If you can, I'll give you a minute. Go ahead and click on the PDF files of the slides, download them, open them if you wish. I'll give you a minute to do this. It'd be possible for you to mark assignments as assignments on Canvas so it shows up. Yes, I can try, Sarah. Let me go look at the home page. Let's see. Let me give it a test, sir. All right. Okay. Yes, look on your home page, Sarah, for the course, and you now see 2 assignments just posted coming up. Does everyone see that from your home page? So it says coming up assignment 6 and rounding numbers with the little rocket. The little rocket, I guess, is a quiz. How they come up with that icon, I have no clue. Okay, so there you go, Sarah. So they do not show up until I turn the assignment on. So I was going to wait till after this discussion to turn it on, but there you go. All right. Thank you for pointing that out. Any other comments or questions before we get started? I'm going to share my screen and show you the slides. We're going to start with significant digits. When I go to that slide, I'm going to go full screen. So if you have a question, either jot it down and ask me, or after the 6 slides, or come in with your microphone. All righty? So let's see if we can share a screen this morning. Significant digits, there we go. All right. Let me just double check. Can you see the screen? Just need someone to chime in and tell me if you can see that. Perfect, thank you. Now I'm going to go full screen, so I will not see the chat box, but again, please write your questions down or put them in the chat box or chime in vocally. So now these comments are based on the assignments that we did last week when we are using these tools and learning a little bit about significant digits and how to round. Okay, and so some of this was intentional on my behalf to see, okay, let's see what we can do, what we might remember from other places. And some of it was just me assuming or, yes, making a mistake. So here's what we're doing. All right. So what's in a number? There are basically 2 categories or 2 types of numbers. Some are called exact numbers, and the other one would thus be inexact numbers. Now, the terminology inexact numbers is not used by statisticians very often. Usually you will see the term measured numbers, but it means the same thing. So these are just differences in these two types of numbers. This will be intuitive, and meaning that you already know this. I think what will be new is we're going to actually identify these two types of numbers and give them specific names. But you already know this. You do this every day. Okay, so exact numbers are things you count, and they're defined numbers. They're whole numbers or integers. There are no fractions. There's no uncertainty in these numbers. When you count the number of fish in a tank, that you are very certain about how many fish are in the tank. It's not 12.3 fish. It's not 6.8 crocodiles, right? It's a whole number, and you can't simplify the number. Now, technically speaking, there are an infinite number of significant digits. In other words, if there's 12 crocodiles, there's 12.0 crocodiles. There's 12.00 crocodiles. There's 12.0000 crocodiles. Okay? But who really writes that there are 37.00000 goldfish in the tank, right? That's ridiculous. So this is why you see them written as whole numbers. The other type of number this will include are percentages, right? So that's basically the unit is 100. So 0.67 is 67%. Okay. So these are exact numbers, right? There's no uncertainty in these numbers. Now, everything else is more or less a measured number. What is the length of this pencil? What is the frequency of this sound? You know, things like this. And because they are measured, two consequences. Number one, you can get numbers between two whole numbers. In other words, you expect to see fractions. Okay, so this is where all the decimal places come into play. And the second is these numbers, because they're measured, come with error. Ready? They come with error. There is some uncertainty present. So this error then is the element of statistics. Now, when we measure something, the idea is to have an idea of how accurate is that measurement. Remember, go back to our terminology from last week, accuracy versus precision. We want the real value, we want the true value. So the accuracy reflects our ability to get close to the true value of the single measure. Okay? Accuracy obviously increases the number of significant digits. So if I say the distance from my house to hockey rink is 3.2 miles, but I'm more accurately saying 3.16 miles, or 3.1582936 miles with more significant digits, with more decimal places, I am thus increasing the accuracy. However, remember, that comes with error. Okay, so we have this game we have to play, right? Just a sec. Unplug that for me, boss. Sorry. So we have this game that we've got to play. Accuracy versus the error. All right. And so this whole next set of slides is based on how do we use notation to describe the number of significant digits, which reflects the accuracy. Okay? So rather drawing this out so we're on the same page, but if you know this, my apologies, refill your coffee cup. All right, so the idea is then how many digits are significant when we see a number? There are three basic rules to follow. Follow the rules, you will not go wrong. And the rules are non-zero digits, so anything other than a zero, are significant, regardless of where they are in the number. Okay? So anything that's not a zero is significant. Any zero that lies between two non-zero numbers are significant. So if the zero is bracketed around two non-zero numbers, the zero becomes a significant digit. Zeros at the end of a number are significant if and only if they fall to the right of the decimal place. Okay, so if they fall to the right of the decimal place. If they fall to the left of the decimal place and are not bracketed, they're called placeholders. Okay, they're called placeholders. They just give you a sense of scale. So number one there, 1400. Non-zero digits, yes, the 1 and the 4, so they're at least 2. Any zeros between non-zero digits? No, there's no zero between the 1 and the 4. Zeros at the end of a number, only if it's to the right decimal place? Nope. Those 2 zeros are to the left of the decimal place. The decimal place is technically not written, so that is 2 significant digits. Now, if we add a decimal place, the 1 and the 4 are still significant, and now the 1 0 to the right of the decimal place becomes a significant digit. Okay? If we look at number 3, we've just moved the decimal place around. So anything to the right of the decimal place is a significant digit. So now we have 4 significant digits. The 0 to the left of the decimal place is not a significant digit. And I guess I'll state now, it's standard notation. It is standard practice that when you write a decimal, you put a 0 that precedes the decimal point. Okay? Unless there's some non-zero number there. So if it's 7.14, you don't need a 07.14. Okay? So you typically put a 0 there. Why do people do this? I'm assuming it's to indicate to the reader that there's a decimal place there. If it was just 0.14, I guess the decimal is easy to overlook. Okay? That's Dr. B making up a story that seems illogical to him. Okay? Now number 4, we've got a 1 and a 4, so we've got 2 significant digits. There's no zeros between the 1 and the 4. And the zeros at the end of the 1 and the 4 are 2, so it's still 4 significant digits. All the zeros to the left are placeholders. And 1.4 times 10 to the 3 is scientific notation format. And that's the same as number 1. If you multiply 1.4 times 1,000, you get 1,400, and that's 2 significant digits. Now, there's the easy way to do that, and that is you just count the 1 and the 4. You basically can ignore the exponent in the form of scientific notation. So 2 significant digits. All right, so we're just playing here by using these 3 rules. Okay, and this is what we're going to have to practice. This is what we're going to have to practice. And this is what our quiz this week is going to be based on. All right, so I'm going to go on. Now, this is just to expand that last idea about a 0, because zeros seem to be the most complicated element of this, right? Does the 0 follow? Is the 0 before? Is the 0 in between 2 numbers? What the hell? Just make a rule, okay? So this just expands on that idea of zeros. So zeros are not significant, and it is the only digit preceding the decimal. This is what we just talked about, and you write it like this because this is standard notation. I didn't make the rule up. This is one of those deals where you just got to follow the rule. Okay, zeros are non-significant if it precedes a non-zero number but still follows to the right decimal place. So based on our examples we just saw, right, this confirms that there's only 2 significant digits in 0.047, the 4 and the 7. All right, it's the only value trailing whole numbers. So all those underlined zeros are not significant. They're just placeholders. They're telling us how many items. Okay? Now, that's the general rule. And obviously, if it precedes a whole number, it's not significant, but typically you don't write 021 when you're talking about 21 pine trees. Okay? There's some probably rare exceptions when you do that, but that's more for formatting than anything else. Okay? So we're not going to. Number 4 is a no-brainer. Now, it gets messy. Okay, so think about this. It gets messy because remember, we went back to an exact number. If you counted 360, 360 amoeba on their slide, that would be an accurate measurement, right? That would be an exact measurement. That means that we can't get any higher degree of accuracy, and there's an infinite number of significant digits. In this case, that would suggest that the 0 is a significant digit. Okay? Yep. So you have to be careful about how you write this in such things. So if you just wrote 360 and I said how many significant digits, you would say 2, 1 for the 3 and 1 for the 6. If we were counting amoeba 360, we could argue differently, but then we would have to write it differently, such as number 3, where it says if 3 places were significant, then you have to write 3.60 times 10 to the 2, which is 360. But because I got 3 decimal places, or 2 decimal places, the 0 becomes significant. Okay? So I want you to just think about the 3 big rules. Think about when the 0 is significant and not significant. Don't stress out about the scientific notation. Pay attention to ignore the exponent, and pay attention to the decimal place. And that will tell you the number of significant digits, even if it's written in scientific notation. Okay? When it gets messy like that, those examples in blue, you'll be told from the context of the story, okay, as to how many significant digits. In other words, is 363 or 2 significant digits, okay? But if you were just said, if someone just asked you, 360, how many significant digits, you say 2, right? We'll worry about the weird exceptions later, okay? So use your 3 rules. Pay attention to the placement of the zeros. For whatever reason, they seem to be the trickiest part of these discussions in determining the number of significant digits. Now, as you did in your homework, it's not just significant digits that you measure using a ruler, for example, or a scale, but then you do things with those numbers. You calculated the average. You calculated the standard deviation. And so every calculation then also has to reflect an appropriate number of significant digits. Okay? And there's 2 rules for determining the number of significant digits. One rule applies to addition and subtraction. And the rule is you add or subtract as normal, and then you round the answer to the least number of decimal places for any number in the problem. Okay? So you look at the decimal places. If one of the measurements only goes to 1 decimal place, 12.2, and every other measurement goes to 37.35, 37.36, 18.19, 2 decimal places, you have to use the least amount of accuracy in your average. And so therefore, your average would only have 1 decimal place. Okay? And the bottom line is, there's ways you can describe this. So the weakest, right, the chain is only as strong as its weakest link. The weakest link in this example is the data point that has the least accuracy, or the least number of decimal places, if it's addition and subtraction. All right? And so therefore, you can't have an answer that is more accurate or has more decimal places than something that doesn't. That should just be kind of intuitive, right? You can't get a better answer from something starting with product that is not as good. So multiplication and division have a different rule. You multiply and divide as normal, and then you round the answer to the least number of significant digits for any number in the problem. So here it's not decimal place per se, it's just which is the number that has the fewest number of significant digits. So which data point has the fewest number of significant digits, and that determines all other calculated answers with respect to multiplication and division. Okay? So 2 rules based on whether you're adding or subtracting and assessing the number of significant digits. So here's some examples. So addition and subtraction will have the same rule. 1.2 plus this number plus 18. We can go ahead and add it up. What is the fewest number of significant digits? What is the least number of decimal places? The 18. There is no decimal place. So therefore, I would say if we were to write our sum with the appropriate number of significant digits, it would be just 20. Just 20. So this measurement in itself, really useless. All that accuracy, because this one is not. This is the one that determines the rounding. This becomes 20. Now at this point, you use your standard rounding rules, right? 0, 1, 2, 3, or 4 gets rounded down. 6, 7, 8, 9 gets rounded up. If it's a 5, it depends on the preceding number, whether it's even or odd. Subtraction, same thing. you do your standard subtraction. This is the number I end up with, is the difference. This 0.241 has 3 decimal places. This has 5. 3 is less than 5, so I can only have my answer to 3 decimal places. 0 doesn't count. 0.61645, I keep this at a 6, so my answer is 0.616. Okay? Take the same set. Now I'm going to multiply. This is the number I'm going to get. Remember, now the answer is the number of significant digits. This has 2. This has 5. This has 2. Therefore, this answer has to have 2. In this case, it's 8.2. I ignore this. Okay? Division, same thing. 5 significant digits, 2 significant digits. This must have only 2 significant digits. That doesn't count. This 0 doesn't count. The 4 counts. The 7 counts. But this is a 6, so this 7 becomes an 8. So my answer is 0.048. 2 significant digits. Okay? And so, what do I have on this one? Here's just a statement of your rounding answer. Okay, in case you've forgotten. All right? No, that's the last one. So here's what you're going to do this week. You're going to think about this. We're going to practice this. Why? Because you're going to use it for the next 4 years. Okay? And you're going to use it in chemistry. Interestingly enough, mathematicians don't use significant digits. Oh well, physics certainly uses significant digits. So this is going to apply for physics, chemistry, any biology course. Okay, so you're not wasting your time learning these skills. Once you feel comfortable with this and going over some examples, you are going to write a quiz about rounding and significant digits. All right? There are 20 questions. I forget how long I give you to take the quiz. I can look it up and tell you. You get 2 shots to take the quiz. You get the average of your 2 attempts. So you can take it up to twice, and you're going to take the average. Okay? And if you feel good after your first attempt, you obviously do not have to take the second attempt. All right? But this quiz, I'm going to flip to it now. My screen looks different than yours, don't worry. So there are 20 questions. Each question is worth 1 mark. It's going to be fill in the blank, so double check your typing. You have 2 attempts at the quiz. You have 15 minutes to do the 20 questions. The majority of the questions are how many significant digits and some rounding. And then there are a few calculation questions. So I'll give you 2 numbers, multiply them. Give me the product and the correct number of significant digits. Okay, but they should be very easy multiplication questions. You don't need a calculator to do it. Alrighty? So again, 2 attempts. This is going to be due by Friday at 5 p.m. Is that correct? Yes, due Friday at 8 p.m. So you have the rest of this week. So here's what I would do. We finish the day early. I would study up on this until you feel comfortable, and I would just do 1 attempt today in your lab block from 12 to 3 and get it done. And if you're happy with it, you leave it alone. And if you're not happy with it, you can redo it. Now, it doesn't mean you're going to get the same questions, okay? But that's the way it's going to work. And as for all of my quizzes, what's going to happen is it closes at Friday. On Saturday, the answers will appear, and you have 48 hours after the answers appear to go back and look over your quiz. So you end the quiz Friday at 8. You have to wait about 24 hours for the answers to appear, and then you get 48 hours to look at your responses. Okay? So, are there questions on those 6 slides? I know it seems pretty straightforward. The only way to do this and feel comfortable is to do it. McKenna, the slide should be posted. Go to week 5. Some of your colleagues pointed out that I forgot to turn it on. So they should be there in week 5. 2 links. Let me know if you can't find it. See 3 other people typing. Give them a chance here for the question to appear before we move on. Slide 2. This is the slide, Kelsey? This is my slide 2. All right. So 1400, I would say there are 2, the 1 and the 4. These 2 zeros do not count. 14.0, I'd say that's 3. The decimal place counts, and the 1-4 counts. The next one is 4. Because the zeros are on the right side of the decimal place, they count. So the 1, the 4, and the 2 zeros to the right of 4, but not the 0 to the left of decimal place. Number 4 is also 4. Every 0 preceding the 1 does not count as a significant digit. They are just placeholders. And the 1.4 times 10 to the 3 is the same number as number 1, which is 2. And the fast way to do that is just ignore the 10 to the 3 and just look at the number 1.4. That's 2 significant digits. Oh, so Miss Jack, so is that okay, Kelsey? And Miss Jackson has a question on the table. What is the rounding rule for 5 depending on if the number is odd or even? All right, so the way I was taught, if the last number is a 5 and the preceding number is even, it does not get rounded. If the preceding number is odd, then it gets rounded up. Not everyone follows that rule. That's the rule I'm going to follow. Is that clear? I'll try to avoid those situations, although I won't guarantee that I always catch those things. All righty? Any other good questions? Any other questions? See 2 people typing. I'm going to close this. I'm going to stop sharing for a second. I got to close this, and I got to go get another file. It will not let me switch. So if the preceding number is a 6, you would not round it even though it's bigger than 5. So let's say I was going to round. So McKenna, let's say I had 0.165 and I was rounding to 2 decimal places. I would leave it as 1/6 because the 6 is even. If it was 0.155, I would round to 0.16. If it was 0.175, I would round to 0.18. Is that clear? Any other questions? So, see somebody typing up. And now I'm going to go to the graph slides. I've got 6 slides to share with you. Some of the graph information you came across last week in your Appendix H that I posted on that PDF. So these are basically picking up on page 6. Some of that information is there in text form. Yes. Yes. Well, it would not be 0.150. It would just be 0.15. Okay? Because you can't have a 0. The whole point of the rounding is to reduce the number of digits in that case. Yep. All right. So I'm going to go big screen. Hold on to your questions. We'll come back. I'm going to go over these 6 slides in big view. So this is about graphs and making graphs. Graphs are very important. I feel like the graph makes a story, right? If we don't have a reasonable graph that conveys information clearly and emphatically to your audience, you will lose your audience. And the whole point of making this graph is to visualize your data so that you can identify or emphasize a trend. And it's much easier to see a graph than it is a table. You know this already intuitively without perhaps even recognizing it. We're kind of, as primates, we're attracted to visual things. We like graphs. If you see a table, you probably turn and go like, yeah, I'm not even going to bother with the table. Just tell me what's in the table, right? Who wants to read a table of numbers? It is very hard to pick out information from a table of numbers, all right? So the key here then is, how do you make an effective graph, okay? And which graphs are most appropriate for which types of data and the message that you want to convey to your audience. All right, so that's kind of what we're going to go over today, and then you're going to practice this week making different types of graphs. Okay, so in a big picture, here's what you need to do. You've collected a bunch of data. Maybe you've collected the interactions of two rhinoceri, right, based on their interactions with the horns. Maybe you've collected diet data from your rhinoceros study, and now you want to visualize it. And so you need to think about, what is the information piece? What is the result? What is the inference or the conclusion that you want to convey in a graph? Because that is going to affect or help you identify what type of graph will work best for me. Okay? Think about this. Simpler is always better. Simpler is always better. I think most people would rather you make multiple graphs with a single message than make a single graph and you got to pick out 5 different things from it. People do not have that attention span to pay attention to and pick out the details of the graph. It really has to slap them in the face. Here's what you need to notice. So don't worry if you've got multiple graphs to make your point. The idea is to make a point. Okay? The axes and the labels are really important to interpreting the graph. Do not assume that your reader, includes me when you hand this in, is going to understand what's on each axis. And in fact, I would argue, as would at least one other member of the biology department, that a graph should stand alone and that you don't need the text to understand the graph. So in other words, I can give you a graph, a figure, and I say, what does this mean? And based by reading the axes and the title, you can tell me what's going on in that figure. Okay, that to me, that's a really well constructed graph. So don't forget the title. And all right, and the last point here is, don't assume everyone can see colors. Okay, so color blindness it's common in the population. It happens in males more than females because of inheritance patterns, but don't assume everybody can see colors. So I know that's the standard and the format, and of course that's what we see in publication, that's what we see on the news story and in newspapers and on TV. But sometimes you got to reflect and ask yourself, is this appropriate for my audience? What if they're colorblind? Would they still be able to see differences in shades and tones? And perhaps not. And that's why, for example, you never use red and green on the same graph together, because red-green color blindness is the most common form of color blindness. All right, so moving on to slide 2. So now we're going to look at different types of graphs. Again, you already know most of this. We're going to apply some names to it, and I'm just going to give you some ideas of when these graphs are most appropriate and when issues occur. Okay, so whatever notes you want to take. So pie charts, pie graphs, they're called this way because they look like a piece of pie, and then the components are divided into slices. Pie charts are really good for things that you count, for percentages and proportions, and that's about all you use them for. So what proportion of students at SVSU are from Saginaw County versus Bay County versus Midland County versus Isabella County versus Genesee County versus blah, 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 right? You can divide people out by county. All right. These start to fail or become more complicated as the number of slices increases. All right, so you can see in the figure on the right that there's 17 different slices. At this point, you've lost the value of the pie chart, right? You can't read it. There's too many slices. What's the difference between some of those colors? How do I even interpret number 13 versus number 14? What is 13? What is 14 for that matter while we're at it? So I've got a scale and key there, but the key is really poorly constructed because it's just numbered 1 to 17. I still don't know what those 1 to 17 stand for. At least in the one on the left, I kind of know I'm looking at different fruit. Okay, so it's just something to keep in mind. So very good. You'll see them a lot in presentations, particularly budgets, because you can allocate, oh, I spent this much on gas, I spent this much on going out, I spent this much on hockey sticks, whatever it is. Okay, you've got your various proportions. And if you're not buying hockey sticks, you really got to rethink what you're buying with your money, right? Okay. Second graph here is called a scatter plot. It is basically every data point graphed. Now you notice I haven't put axes or haven't put titles on this. That's me being lazy just to demonstrate the scatter plot. And so I have an x-axis, I have a y-axis. This is valuable for continuous data, continuous variables. So things that have fractions. Time is often the most common independent variable on the x-axis. Okay. Now, the idea of using this graph is to visualize if there is a relationship between the variable in the x-axis and the variable in the y-axis. You may not know how they're related to each other, okay? What's important is the individual data points are not related to each other, okay? So they just represent multiple measurements of this variable x and this variable y. So in other words, the data points themselves are not connected. Therefore, you can't draw a line between them. All right. So it makes no sense to, I guess I shouldn't have picked red, but here we go. To connect this with this, 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 or even go this, here, 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 ding, 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 ding. Right. It makes no sense to connect the dots because this dot is not related to this dot, which is not related to this dot, which is not related to this dot. These are just different data points where X was measured and where Y was measured. Okay. Now, again, the idea here of this is to look at the graph, the scatter plot, and just eyeball, do you think that there's a relationship amongst or between the X variable and the Y variable? Okay. And once we master this, we'll learn how to assess that trend. We'll learn how to assess that relationship, and we'll learn how to add a line that averages or splits these values. That's what you see all the time. You see all these dots, and then someone draws a line on top representing the average or trend. We'll worry about that later. Let's learn how to make a scatter plot first. Okay? So I'm very much a person of like, let's learn the skill, but we're going to do it stepwise rather than dump it on you at once. Okay, now this one is different. It's similar. Technically speaking, it's a scatter plot with the points connected. So again, we've got continuous variables. I did a better job of putting some axes on. Days, which is time on the x-axis, and weight in grams. Has to be grams because science class. Okay, so in this particular example, if we connect the dots of the measurements between days and y, the weight, we come up with this trend, right, which is exemplified by the line graph. So similar to the scatter plot, but not quite the same. Okay. All right. So that's 3: pie charts, pie graphs, scatter plots, and line graphs. And we'll do 2 more. One is called a histogram. Now, these are quantitative data points. So I know I'm using a lot of adjectives, and the same term often applies for different people, and they're synonyms in some cases. So quantitative means a number. Okay, qualitative means a quality. So blue, red, orange is a quality. Tall, short is a quality. Okay, quantity is exactly that. Can you count it? Okay, does it have a measurement? So histograms, to me, are very similar to line graphs. We have this continuous data on the x-axis, and the only thing we've done is that we've made categories, is that we've grouped them in categories. These categories are called bins, B-I-N-S, okay? And so here, I've taken all the students. The x-axis, right, is a continuous variable. That's percentage, that's grade. I could have made a pie chart. It would be the same thing, right? I've decided to make a histogram with it. So to me, it's a little easier to see, but it doesn't matter. That's your choice. It's a continuous variable. And then I've decided to lump the values into bigger categories, the category of an A, the category of a B. So obviously there's multiple values in here, right? Anything from 89.9 to 80.0 falls in this range, in this bin, in this category. So statisticians call it bins. They don't call it categories. So in this bin, now I have a C bin, a D bin, and an F bin, and now I lump them together into this graph, and it's very easy to see quickly that the most frequent grade is a B, right? That's my mode, right? It's a continuous variable, so I could draw a line right through the averages on top like that. Sometimes you see that as well. Not worried about it. Second most common grade is a C, and you can see the relative proportions. Okay. So these histograms, you'll notice that the bars touch each other. So these are the bars. A bar is represented by a single bin, or a bin is represented by a single bar. Here's one bar, here's my third bar, 4 bar, 5 bar, okay? And they touch each other. There's no space. That lack of space indicates to you that this is a continuous variable, okay? That this is a continuous variable. I know I'm making a big deal of this because so many people mix this up with a bar graph, okay, with a bar graph. And it's very similar. I have bars. These are bins or categories. The difference is that the x-axis, this is not a continuous variable. Bars cannot touch in a bar graph, okay? In addition, you could always reorder the bars in a bar graph. I could have oak first, I could put birch over here, then ash, then fir, spruce, and pine if I wanted to show you the decreasing values. I could reorder it, showed you the increasing values. I could leave it like this, okay? So you can't reorder bars in this. It makes no sense. I could reorder it the other way and put F here, but then I got to go D, C, B, A. If it's a continuous variable, you can't jump around. If it's not a continuous variable, if these things are distinct from each other, then you can put it in any order you want, and the bar width has to be the same width. Okay? Here, technically it does not, although if you make your bins the same size, it's much easier to interpret. So my suggestion will always be that the bins are the same width, therefore the bar is the same width. Therefore, then you don't have to think about it. Okay? So there are my 6 slides about different types of graphs. So we've got the pie chart, pie graph, scatter plot, line, histogram, and bar. That's 5. Questions for me? Some of this text background you will find in that appendix that was posted last week. I think it's called Appendix H. That gives you some of the written descriptions of the differences between these types of graphs. They do not discuss them all. All right. I'll give you another minute here to ask me a question. Then we'll move on to our last point here. Now this one is going to be an Excel file. So if you got an Excel on your computer and you want to open up a file and just start playing with it while I go along, you're welcome to do that. Otherwise, you can watch and take notes. All right, I'm going to show you some of the tricks and pitfalls in making these graphs in Excel, and then I'm going to turn you loose with an assignment to make some graphs. All right, so I'm going to get rid of this thing again. Come back to my screen share. Let's see. Come on now. It's telling me error. There we go. You have to talk nicely to this thing. It doesn't work. Okay, everyone see my Excel file? Is it large enough, or do you want to make blah, 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 blah? It's Monday. Would you like me to make it full screen? If that's large enough, so I'm not sure what you see. All right, tell you what, I'm going to keep it like this so that I can see the chat box. If it gets problematic, you'll just have to hold your questions. All right, so here's my Excel file. You'll notice at the bottom, I've got different worksheets that I've got different graphs that I'm going to show you on each worksheet. Okay, and this is how your homework is set up, by the way. I'm giving you a single Excel file, and there will be a number of sheets, and you can adjust and move between the sheets, right, by clicking on the bottom. For those of you who aren't familiar with this. Okay, I'm going to get rid of this because that won't show up. Okay, so here we go. There's multiple ways to skin a cat. In Excel, I'm just going to show you some basic tools to get yourself around. As you do this, you will learn tricks that I don't know. You're welcome to share. I will open a discussion post where we call it Excel Tips. You can share with your classmates things you've learned, tricks, particularly if you have a question and can't find me, that would be a good place to ask. Okay. So the first thing we're going to do is make a pie chart and graph. This is called the ribbon up here with these tabs. So eventually, I want to insert a chart or a table. Now, there's multiple ways you can go about this. A recommended chart, I haven't selected any data, and then there's different types. So there's my bar graph, there's my lines, here's my pie charts, here's my scatter plots, here's my histograms, different types of what we call waterfall, different combos, okay? And so you have these options. Your button placement may be a little different than mine. I work in a Mac. I don't even know what version of Excel this is, so be patient if your screen and toolbar does not look like this. If you want to use the recommended, you'll notice nothing shows up. That's because I haven't selected any data. Now I get data. Now I get the recommended. Okay? Now, this is interesting because it's actually recommending to me a bar graph or a pie chart or a horizontal bar graph, which is the same, it's just been rotated 90 degrees. Okay? Whatever they're calling this, like a demographic graph. I'm not going to use those. So it really depends. Since I'm asking you to make a pie chart, let's go pie chart. So let's just be simple, and we're going to click that. You notice that it makes your chart automatically. Hold on here to the corners. I'm going blind, so I want to make it big so I don't have to think. Okay? Now there you go. That's the basic. I can click here. I can call this my super duper fruit pie graph. Now I'm going to have to go get pie, right, for dessert today. And now I have this. So, and then there's different options. So you notice down here, this is called the legend, where each color has been identified by the type of fruit. That's called the legend or the key. Your graphs will need a legend or a key. Where you put it, right? This lets you move things around if you wish. Okay, and this is where you can spend hours just putting around, right? Get the basics down and then move on. Now, I'll just show you a few tricks. If you click this once and you see it highlighted the data that's being graphed, if you ever forget, click on it, it will show you what it is. So let's say I came up with something and I forgot something. I forgot this grapefruit. Who doesn't like grapefruit? And there are only 12 grapefruits. And notice that I don't have that included. But if I go down here to the funky square corner, look at that. It automatically added grapefruit for me. So now I didn't have to remake the graph. Okay. Likewise, if I decide, you know what, kiwis, no kiwis this type of year, they're gone. And now my graph has readjusted itself. Okay, so here's the nice part. You make a big mistake, delete, and you start over. Now here's the difference. If I highlight, I'm just going to do this so I don't have to worry. If I highlight that, just the numbers, and I come over here to insert, and I say recommended, and let's use this one. Let's use this option. Now they got different types. Let's go 3D just to give you a different angle. Now you notice, what is the difference if I highlight just the number versus if I highlight the number and the words? Okay. The difference, too big, sorry. The difference is that here, if I highlight just the numbers, I get this key, but there's nothing there associated with it. Whereas if I highlight the words and the numbers, it actually will fill that in for me. Okay? So it really depends. It depends what you want to do and how you want the look. When you get really fancy, you can click on this at the insert. Okay, so I've got that. Okay, you can change the format of this if you wish to different types. So if you just click back, it changes it, blah, 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 blah. Okay, the rest of this is really you just playing around and messing with it. Now, if you go here to format data points, look what happened at the top. Okay, the chart design shape, this came up automatically. I just double clicked the graph. Now I got format data points where you can change the color. So if I click twice, see how just this piece of pie is selected with these 3 data points. I can change the color on that if you want. So remember what I talked about, some people are colorblind, so we're going to go white is not we're going to go 62 shades of gray. Hey, isn't that a movie? All right. Okay. And so now if you're colorblind, you can still figure out what that is. Maybe a little harder, but you can do it. If I click here and go back to the data points, it shows up. And if you just want to play around, pull this down. Now I can get it here. It will put in proportions for me. I can change it to that one where the words are actually included in there. So now I get rid of the index, the key. Here it puts it around the outside with the percentage. Now you notice it changed the percentage from a real value, from a counted and exact value, which is the point of the pie chart, right? The pie chart shows you percentages. Okay, so you can play with this all day long. And the more you play with this, the more comfortable you feel, right? The less intimidating this is. When you don't do it for 6 weeks, then you come back and you're like, how the hell did I do that again, right? Take notes as you go. This is what I do. I have a full 2 pages of notes here just to remind myself of how I got to this, that, or the other. Okay, so pie charts. Questions about pie charts before we move on. And of course, there's 9,225 different videos on YouTube telling you how to make graphs. If you get flustered or you want to do something that you just can't figure out, which is frequent in Excel. It's not you. Okay, it's not you. All right, scatter plots. Hide this. Now, same thing. I'm going to highlight my data. I'm going to go to insert. Insert is always the key. Scatter plot, and there it is. Okay, now you notice how small everything is. Okay, I can tell I'm getting old. I don't even want to look at that. So I'm going to put my title in here. Okay, it's a fancy title. Now here's the trick for this. Here's what my suggestion. You're going to highlight. So I got a box around the x-axis. Do you see that? So the box is around the x-axis. After I highlighted the x-axis, what happened on the sidebar, this is called format axis came up. I can change the numbers and where these lines appear in the graph by messing with this. Check marks refer to the little indentations or the little lines between 5 and 10. So the major, for example, if I go outside, it's hard to see, but there's a little tick mark, a little line extension at the numbers. If I go, now you got to be on this sub option. Okay. So that one is color and fill. This one is shadow, junk. This one's alignment. Here we go. Tick marks. If I go minor, outside, now I got a bunch of tick marks across the bottom. Okay. I can change the label position next to the axis, high, low, none. I don't see a difference between much of those options, but you're welcome to play with them. Options. I can change the maximum. So I know my highest value is 20. If I want to go 21, why when it goes to 0? You got to watch it. Okay, so now it only goes to 21. Is that good or bad? I don't know. It just is. You can decide. Okay. You can change the intervals. So right now the major unit means 5. So it goes 0, 5, 10, 15, 20. Change this to 2. All right, now I'm going to get intervals of 2. Okay, just little tricks. It really depends what you want. Here's my one suggestion. I'm going to highlight this. I'm going to go back to home. I'm going to make it bold, and I got to jack up the font size because I can't see it. Now here's, you got to do the y-axis the same, right? Changing one axis does not change both. Okay. All right. Here's the last trick I'll show you with this. If you click the point, you'll notice you'll see the data that was all highlighted to make the graph. Okay. So the same thing can apply. Let's say I had 14.5. I forgot a data point, and it's going to be 14.3. Okay, so I'm going to click this, extend this, and extend this. I added the data point. Okay, and I didn't have to do that. I didn't have to redraw anything. Now, one more. So here I can go to this. If I go over here to format data series, so you know that's not axes anymore. That's data series. And if I go to something called marker, this is just really playing. Marker options. I can change the shape. I don't know. Let's say I like triangles. Okay, and it's too small for me. So now now I can see something. Okay, so that was done by clicking the marker. This is called the marker. You go over here, just keep clicking around until you see something that says marker. It keeps closing on me, and I can change the marker. Don't like the color? I can change the color. That's the color inside. Here's the tricky part. That's the fill. You got to imagine your triangle or your marker has two parts, a border and a fill. If you want to fill, but you want a fancy black border, or you want a fill that's yellow, but I want my outline to be really bigger. Now I got a fancy marker. Okay. So again, the point is to make the graph first, then you can mess around with the stuff. Okay? We will come back to this later, but if you click the entire box and you select and you edit and copy this, so you copy it, you can paste it directly into a PowerPoint, and you can paste it directly into a Word file if you're making a lab report or something. Okay? We're going to practice that later, and how you get the text to move around. All right, scatter plots. Now, what's the value of a scatter plot? Here's what I was taught in stats. You always begin by making a scatter plot, because this will often show you where errors are in your data. And I mean data entry errors or measurement errors. So let's say this is my pattern I expected, and I added this data point. Immediately, I could look at that and go, whoa, something's wrong with that. Let me go back and look at my original data. Did I miss a decimal place? Everything else is to one decimal place, and that's a 35, which suggests that should be a 3.5, right? You would only be able to pick that out if you make a scatter plot. So it's very good for figuring out outliers and errors either in data entry or whatever it is, okay? So even if you never plan to use a scatter plot, the way I was taught was you always begin with a scatter plot to look at your data. Okay, line graph, same thing, very similar. Tools, delete it. Okay, I can do this. I'm going to go back to insert. I'm going to go here to line graph. There it is. Now it's giving me two lines because it's interpreting both of these columns as two different lines. So if you don't like that, just delete it. Here's the data I'm interested in. Insert, line graph. There's my graph. Okay? And then you can go and change all your doohickeys, as the title, the axes, whatever it is. You can come back over here. I don't like that color. I like taupe. And you know what? I actually want to make it dashed because I'm that kind of mood today. You know, whatever it is. Okay? Now, what did you notice in this particular case? Is that the x-axis is labeled 1 to 20, which is good in this case, or it's consistent with the days being 1 to 20. That does not always happen. What if this wasn't labeled 1 to 20? What if this was 1, 2, and then it was 4, 8, 16, 32. Remember the cancel. Remember this trick? Once you get your pattern, you just drag and drop and it continues the pattern. No, it should continue the pattern. Oh, I don't know what I'm doing wrong. Okay. Okay. So you'll notice that I selected that, and that's what I got on my x-axis still. It's still reading it as the first data point, the second data point, the third data point, but that's not really true, right? Because these represent something else. And you'll notice that it still doesn't work this way, right? It's still reading this as 9 or 10 data points and not the value. So I'm not sure, here's a shortcut. If you get frustrated by making line graphs, just go back, make yourself a scatter plot. That's got the data points you want that match the x-axis, right? Then you highlight it, you go to line, and you add your line in. And now you have your line graph, but your x-axes are consistent with your input data, okay? So that's what I do. That's what I do. When I get frustrated, when I get pissed off with that particular tool of making the line graph and I can't handle this anymore, I just go to make the scatter plot and I add the line. And it's the same thing. I just can't be bothered to figure out the rest. Okay? I'll show you one trick because I made this graph. You notice you got 4.5, 4, 3.5, 3. Now we know now that that's inconsistent. If we're going to have a decimal place, we want everything to have one decimal place. Let's see if I can remember how to do this. Okay, so I highlighted the axis. Here I am in format axis. That's just confirming to me that I've highlighted the axis. I'm going to come down here to number. And let's see, number, where's decimal? Oh, I'm going to click number. All right, so it was on general. Okay, so it was on general. So if I take the category and I click it to number, use decimal places, I can change it from 1 to that, and now everything is consistent on the y-axis. So highlight the y-axis. I went down here to number. I chose the number category. So in other words, you can play around with it. You can put scientific notation. You can make it a date, and now it changes it to dates, okay? And you can just mess around with it till you're happy. But that's how you can make the numbers consistent with respect to the decimal places, okay? I know we're going quickly. I'm trying to give you the major hints up front of how you can get this done. The rest is going to, unfortunately, there's no way around it. You got to spend some time just putzing around with this, okay? But the time you invest now with your notes will pay off later. All right, I'm going to show you the last two. Now, the histogram, remember, here's my original data set. Here's student and final grade. Okay, so there were 30 students. Here's their percentage. Now, I can't make a histogram of this because if you go back to that idea, it has to be binned, right? It has to be binned. What are my categories? I want my categories to be A's, B's, C's, and D's, right? So I'm going to go and make them all the same decimal place. But the way it's written, those are not A, B's, C's, and D's. So here's the first thing I'm going to do. I'm going to take this, I'm going to copy it, I'm going to paste it. Okay, there are my grades. While it's highlighted, I'm going to go up here to Data, Sort. Okay, and now I get this box. I'm going to sort it by column F. I'm going to do the values, and they're going to go from largest to smallest. And when I click OK, it reorders them all from largest to smallest. So how did I do that? Data, sort, and then you tell it how to sort. Column F, I'm going to sort based on the value, not some other metric like color. And I can go to smallest to largest if you want. Doesn't matter. And now it's going to reorder. Now it's much easier to bin things. So I know that an A is 90 or above. So there are my A's. I got 4 A's, 12 B's, 8, 4, and 2. The trick will be to make sure that this adds up to 30 and that I have 30 values. I have 30 values. Okay. Remember that tool last week? They call it the count tool. If I put my equation in there of equal count, parenthesis, I highlight that, close the bracket and enter, it adds up to 30, that adds up to 30. It's just a way to double check that you're doing this correctly, or you got all your values. Now, with my bins and my values, now I can make my histogram. Why did you do that? You did that to me yesterday. I don't want to do that. All right, so this graph, what do you notice is wrong? It's making it from most to least frequent, but it's taking this out of, right? It's supposed to be a continuous variable, but it's not maintaining that. So let's get rid of this. This happened to me yesterday. I don't know what I did differently. No, I don't want that. Why did I do this yesterday? This is the great fun. Oh, I think I got an idea. So this is, hey, have I used this before? Yes. Would you know it? No. All right. How's this doing? Anybody know what I'm doing wrong? I can't remember how I fixed that. All right, but this is what I got. This is what you ended up with yesterday. You can highlight the bars. You can change the colors. Now, typically here, you don't go with different patterns because this is one continuous variable. Okay? This is one continuous variable. I'll have to come back to this. What did I do differently last time? All right. All right, and the last one here is a bar graph. I'm going to show you 2 tricks with this if you have the patience. Okay? Here are my trees. This is my raw data set. Okay. I'm just clicking on things. No reason. And here are my list of different trees. Let's get rid of this. All right. Now, again, if I want to make a bar graph, I have to be able to bend them, bin, and then I have to count them. Okay? And so the worry here, or one concern is, did you collect all your data points? So I can go 1, 2, 3. I can highlight this, scroll all the way down. I should have 32 values. If I've added it up correctly, this should add up to 32. So there's my, I can auto sum. There's 32. So I added them up correctly. Okay. Now, what if it was a really long list that stretched all the way down and there are 535 of them? So you're going to go down this list and count spruce every time? I think probably not. You'd probably just not do that assignment and say, yeah, whatever. Right? I got other things to do. So here's an alternative. There's a modification to that count. And so watch up here in the formula bar. So an equal sign means a function. Count if bracket, I have to pick the range, okay, and then comma, and the criteria is what do I want? Oak. What did I type in wrong? I gotta have the there. Okay, do you see that equation? So that counted if, the if means the condition of oak, and that was the range it looked for oak. So then there were 10 oak trees in that range. And so then you can just spare yourself the time if you ever have to do this. So you can do this the same way, right? I can take this, I can copy, and I can paste it. That will be oak. But remember, go back to that problem, remember about maintaining your ranges. So in other words, in this case, if you wanted to keep the range, you'd have to put the dollar signs if you didn't want them to move. I know I'm going a little nuts now, what I'm showing you. I'm just trying to show you some other tricks. So now that keeps the absolute range. You could, okay. Yes. And if I scroll that down, it should all be 10. And now if I change oak to fir, there's fir, how many fir trees there are, okay? You could have just typed the same equation in 5 times. Doesn't matter. Now I'm going to get this. All right. Insert this one. Here we are. Okay. And you can go through the same rigmarole. Highlight the axis. You can adjust your axis if you want. Are there tick marks? What is the highest value that you want? What is the smallest value that you want? You can change the names here. Home, bold, size 28, so old people can read it. You can add your title to this, right? Super duper tree count. If you want to go different, you can highlight the bar. So that's all the bars. See how they're all with the circles? Click it again, you get 1 bar. Come over here to the paint can. I can change the fill to gray. I can select this one. And then here, I can use a pattern. Okay, so a pattern, these are dots. So the foreground will be the dots, the background will be white, and now I got dots. And you notice that there's no line around it, so I can highlight it again. I need a border, I need a solid line. There's my line. Okay, so I got it. This is going to take you a while to figure out. That's okay. That's okay. Investing some time now will pay off later. So I know that's a quick mash through this. I didn't get the histogram right. I can't remember what trick I used yesterday, even though I got a page of notes here in front of me. Okay. To Google things on YouTube, they're probably clearer than the explanation I've given you. We'll show you better tricks. We'll show you different tricks. The idea here is to make it, and the more you do this, the more tricks you will learn. Okay? So this week then, if you go back to page 5, our week 5 module, I'm going there now, even though, all right. There is a second homework assignment. It says use this Excel file. You're going to download the Excel file and you're going to practice making graphs. Inside the worksheet, or sorry, inside the file, there are multiple worksheets. The data set is already there. All I need you to do is to make your figure. I want you to add a title and axes for every figure. And then when you're done all 5, you're going to submit your entire Excel file to me through the assignment link. It is due Friday by 8 p.m. So both of these things are due Friday by 8 p.m. So that is your significant digits rounding quiz and this assignment. So you got a busy week and all your other courses. If you did one graph a day, you got it done by Friday at 8 p.m. Okay, or if you take the remaining 2 hours of this class, 2 hours 45 minutes of this, 1 hour 45 minutes of this class that's remaining, and you took care of your quiz, you're done. Okay, some of the graphs will be much easier to make than other graphs that you saw by the time you piddle around. The bar graph looks pretty straightforward. The pie chart looks pretty straightforward. Okay. Questions for me? Anything and everything we've done. Any Excel experts out there that want to tell me what I did wrong on my histogram? Why I couldn't, what I did wrong? You're a quiet group. There's 17 of you here. There's a lot of zeros in the grade book for missed assignments. Okay? Can't go too much longer with all these missed assignments. Questions for me? So I'm going to make a discussion post through the discussion link, and it's just going to say Excel questions and tips. So I encourage you to contribute and look there. If you have a problem, post your question, and if you understand and can reply, reply. My experience is that your students are often much more willing to talk to each other and learn more from each other than you will listening to me. At least that's the way it works for my kids. Sure, there's no questions. Did we go too fast through the Excel? It's about the right pace. I mean, I can show you junk all day long. The bottom line is you're not going to learn it until you try it. And that's the only way you're going to learn it. I'm just trying to head off some major problems. Okay. So I'm going to hang out here for another 10, 15 minutes or so if you have questions. If you don't, complete one of your 2 assignments now before 3 o'clock, since you got the time blocked off. Either start working on that quiz or start working on some graphing. Even if you just open up download everything, you open it up and start making graphs for fun and playing around. Okay? You're going to leave your graph, the figure that you've made, on that worksheet. So when I open up your file, I will see whatever it is, 5 tabs. I'll go to each tab and your figure, your graph will show up with axes labeled and whatever I'm trying to say. With axes labeled and your title. Okay? Okay. It's a quiet group. So if you're good, have a good afternoon. I know some of you are in my 181 lecture session. You don't forget you got a test this week, this Thursday. We're going to have office hours on Tuesday to take up questions. So you put the $ in the formula bar to hold the range constant. Okay, so in other words, you don't want the range or the cell identity to move or change. Okay, it's called an absolute reference, I believe. When you do not add the $, the cell boundaries change if it's a formula. And so therefore you may not be calculating the right thing. I suspect that happened to a couple of people when they calculated their standard deviation or something, or their sum of squares, that the range of the cells was not correct. But it will come with practice, Emily, and it will become intuitive if you pay attention to the numbers and you're getting the same number for everything, or the numbers differ for everything when you're using the same reference point or the same denominator. Should raise a red flag of something doesn't seem right. Right. So I posted a discussion about using Excel. So from your discussion tab, you should see it if you got a question.